Hello class, this is just a continuation on the integration utilizing logarithmic functions. So let's get straight to it. So we should always check first our asymptotes. So x squared plus 2 equals 0. Solving for x here. Plus and minus square root of negative 2. As far as we're concerned with this doesn't exist. So for this, there is no asymptote that we know of. So we can continue with this integration as per usual. Now, integrating this is not as obvious, but for situations such as these, I always check the denominator, and I let the denominator equal u. So u equals x squared plus 2. And I derive this in terms of x, so du on dx equals 2x. If I notice that this derivative matches the numerator, I know now that we're going to be utilizing ln of x. So I'm going to make dx the subject, multiplying by dx. I'll do this in steps. Dividing by 2x, so 1 on 2x du equals dx. Substituting these in, my integral now becomes from 0 to 1, 2x on, I'm going to let this equal u, that's going to be u, dx is now going to be this expression, so times 1 on 2x du, crossing those two out, leaving us with 0 to 1, 1 on u du, and that's just the basic integral of ln of x. This is going to be ln, absolute value of u from 0 to 1. Resubstituting u back into our expression, this becomes ln of x squared plus 2 from 0 to 1. Substituting all these values in, substituting 1 first. So this will be ln of 1 squared plus 1 is 3 minus ln 0 squared plus 2 is just 2. And that's what we have here. In actual fact, we can do some log laws. Subtracting by the same base of logs, this becomes ln of 3 over 2. And this is our exact form. We'll take an approximation for this. 3 over 2 is 1.5, so let's go ln of 1.5. That's approximately 0.405. There we have it. Let's move right along. Whoops, my screen's freezing. Let's reset this. Once again, always checking the denominator. Let's let the denominator equal u. So u equals 9 minus x squared. Deriving u in terms of x, so that's going to be du on dx equals negative 2x. Notice how 2x, negative 2x, is rather close to just x, so this will work. I'm going to rearrange this to make dx the subject, so du equals negative 2x, dx, dividing by negative 2x, that's going to be 1 on negative 2x du equals dx. I'm going to be substituting these two expressions into my original integration. So this is going to equal 4 to 5 x on 9 minus x squared is now going to be u times dx is now going to be 1 on negative 2x du. Notice how these x's will cancel, leaving us with, okay, I'm going to skip a few steps. I'm going to factor out the negative half on the outside, so negative half on the outside, 4 to 5 of 1 on u du. Oh, once again, as you can see, this is just half from this one here, ln of absolute value of u, but I'm going to resubstitute 9 minus x squared, so 9 minus x squared. Remember, always absolute value from 4 till 5. Substituting 5 first, that's going to be negative half ln absolute value 9 take away 25 is going to be 25 take away 9 is can't be bothered anymore. Let's just do this here. 9 take away 25, that's absolute value of 16, so absolute value of negative 16. So we've substituted 5. Let's now substitute 4, so it's going to be minus negative half ln of the absolute value of 9 take away 4 squared, so 9 take away 4 squared is 9 take away 16. It's going to be absolute value of negative, negative 7. So this is really negative half ln of 16 plus half ln of positive 7. Going to factor out the halves, so let's make this, let's factor out a negative half actually. Negative half of ln 16 minus ln of 7. Once again, using our log laws, subtracting by the same base of the logs, this becomes negative half ln 16 over 7, and this here is our exact value here. So let's find an approximation for this. Negative half ln 16 on 7. This is negative 0.413. Let's do one more example here. Definitely going to need some more space. Once again, checking our asymptotes. So 1 minus x cubed equals 0. Negative x cubed equals negative 1. Taking the cube root of both sides, x equals negative 1. Does that seem correct? Let's double check. The cube root of negative, oh sorry, I completely missed it here. Let's do this one more time. We take the negative first, that's x cubed equals positive 1, so dividing both sides by negative 1. And now we take the cube root of both sides, x equals 1. Now, because our asymptote is at x equals 1, notice how our boundaries cross through the asymptote. So we can say that this is unable to be done. So we can say this is undefined at x equals 1, meaning we cannot integrate this. Thankfully for us, because we've run out of space and time. Well, I hope that gave you an insight into integrating, utilizing the logarithmic function, and evaluating integrals. Hope to see you in the next video. Best of luck.